Hello all, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about kidney stone flexion and stone analysis using image processing. I'll explain you the abstract now. Our main abstract is this process is to detect the kidney stone from the digital ultrasound image of kidney by performing various image processing techniques. Due to the varied texture and extent of speckle noise, detecting regions of interest in ultrasound pictures is a difficult process. Ultrasound scanning is the most common method of examining a patient for a presence of kidney stones. Here, we create an application that aids the multiple practitioner in selecting the region to be evaluated for the presence of stone using the suggested technologies. The feature extraction is done on a cropped portion that may have stones in them. The KNN classifier is used to categorize image based on the training data. This is the introduction part. Yeah, in our introduction, the person with a kidney stone exhibit common symptoms such as fever, discomfort, which might be taken for other illness. Kidney stone identification is critical, especially on early stage. To receive adequate medical treatment, the presence of stone in the kidney reduces renal functionality and can potentially cause dilatation. People who have never been diagnosed with the ailment will be affected by a severity by chronic kidney disease, chronic renal failure because of its some chronic character. It is frequently detected during medical examination of other diseases such as cardiovascular disease, diabetes, and other medical problems that predispose to urgently apparatus. Today's computer assigned tools like ultrasound imaging, computed tomography, and X-rays gives the most accurate diagnosis tools for kidney stone screening and diagnosis. The main objective of this project is to detect the kidney stone from a digital ultrasound image for the kidney by performing various image processing technique. Further, enhanced ultrasound image will be used to locate the exact position of the stone. The main motive of the project was to develop an elementary and straightforward technique to find the stone in the kidney. This detection can be done in available PCs, and hence any normal being can check an ultrasound for kidney stone and dissolve it in the stone. I will explain you the workflow. So we'll have a good diagram. Before that, I will explain the problem statement. Our current method for kidney stone detection in medical imaging lacking precision and reliability, leading to potential misdiagnosis or oversight of small or stubble stones. The manual analysis of kidney stone is labor intensive and time consuming for healthcare professions, delaying diagnosis and treatment initiation, ensuring the development technology is accessible to healthcare facilities of varying resource and that its implement does not significantly increase the cost of diagnosis and the treatment. Our objective in this project is develop algorithms or image processing technique that can accurately detect the presence of kidney stone in medical imaging such as ultrasound, CT scan, or X-rays. Early detection aids aids to timely intervention on treatment. This is our mission. Our mission is nothing but a primer mission is to develop and implement reliable and non-invasive early detection methods for kidney stone. Early detection enables timely interventions, preventing complications and reducing burden on patient. To ensure precise and accurate diagnosis, the mission is to image technique, laboratory tests, and analysis methods that can accurately detect and characterize the kidney stones. And this is our vision. It's the scope of the project. The scope of the kidney stone detection encompasses various aspects related to identification, characterization, and management of kidney stones. Here are key components with its scope. This includes the development, evaluation, and ensuring seamless integration of kidney stone detection. Technologies into routine clinical practice, enabling healthcare providers to effectively use and interrupt the results for diagnosis and treatment planning. Existing system. So these are the existing system that's already available in the market. I'll explain you the workflow. You have a good idea on that. so that you can, so that you have a good idea of the project. Yeah, this is a workflow. So, yeah, this is a workflow. First of all, we collect the data set from Kaggle. We put the process that in pre-process in the sense we put do all the image or height which in one size before giving the serial model. Before that, we will do segmentation and in feature extraction, we could extract those features from the image by using CNN layers. That would be a main layer. I will explain you while the training code. And this is the train. After this feature extraction, the feature extraction will be trained by the model. After that, after the model, you will save the model and you will take that model down to your testing code. With the testing code, you classify the image. So this is what happening in your so this is what happening in your project. Now I'll show you training code. Now before that, I will show you our data set. Yeah, this is our data set. Total six classes. Yeah, this is our training code. Target is six because we have six classic designs. Path is nothing but our dataset path. Here we will load our path, that is dataset, and it will extract the file names and the temporal targets. File name is nothing but it will extract the names of the files, and this is what we'll do is here we will encode the targets, that is image. Then we are doing encode here and it will return as files and targets to load dataset. And then our path will be separated as training files and test files. And these are the statistical about of the dataset. Here it will be printed total categories in the dataset, and total images in the test training files and test files. Yeah. And then here you will convert your 3D image to 4D image. Yeah, this is what you will be doing here to the path to tensor. Then it is a graph. It will be showing your training graph. So that this is what will be printed. After this, your model will be composed. This is your model, and these are the hyperparameters that will be given to your model. And here I have used first of all 64 layers, 632 layers first, and then we have used 64 layers. So the image will be extracted 32 layers, 32 pictures, and then 64 pictures for all the images. And your model will be compiled to already compared here, and you train tensors and train targets. What you have given here will become here. So we are fitting the model to the test values. For that your model will be saved as training this unit here. Before that, you could see how was the curve. The curve will show that how well the model fits to your data. So that you will see in the here. So it's a trained model. I'll show you testing code. Yeah, this is our testing code. I'll run this now. Yeah, this is our GUI. First I will browse the input, any one of the data set. Yeah, this is our data set. In this, I will input any class. I will put this. Yeah. Now I'm turning it to a Cree conversion. After that, K means and fuzzy means. And finally, you can see that our predicted image is calcium oxonate. Thank you for watching our Aislyn Technologies YouTube channel. For more videos, follow our Aislyn Technologies YouTube channel and don't forget to like, share, and subscribe. Thank you.